lab for magnetic field of a bar magnet. So this is a preview of the results. From our experiment, we found that the B net was 8.105 times 10 to the negative 5 Tesla, whereas the theoretical was smaller than this. And on the left, you can see our experimental measurements, and then on the right, the computational model results. So the purpose of this lab was to measure the distance dependence of the magnetic field due to a small bar magnet and compare this measurement to calculations predicted by Biot-Savart law using code in a computational model. Also to use the Biot-Savart law and distance dependence formula, and to analyze changes in magnitude and direction of the magnetic field due to a bar magnet when moving it closer and farther from the magnetometer. So these are the physics principles, the Biot-Savart law equation, and we also use the on-axis and off-axis formulas, and then also the bar magnet distance dependence formula. And before, if you saw in the graph we made from the experimental measurements, we got a equation for the line, and that can be plugged into the distance dependence formula. So the initial conditions, assumptions, and approximations. The system was the bar magnet, and the surroundings was everything else. So the Earth, phone, other potential magnetic fields in the surroundings. And the initial conditions were that the magnet was placed on the east-west axis, and we approximated the magnetometer by an iPhone app. So the experiment details, we used a magnetometer app on an iPhone and a bar magnet, and aligned the magnetometer with the Earth's magnetic north-south axis and meter stick with the east-west axis. We then aligned the magnet with the east-west axis so that it was orthogonal to the Earth's magnetic field. And we located the magnetometer chip on the iPhone and marked the spot for our future measurements. And then we measured the distance between the magnet and the magnetometer chip on the iPhone at multiple BX values. And then we plotted the natural log of these BX values versus the distance to evaluate the distance dependence of the magnetic field due to the magnet. So here are the pictures from the experiment. So as you can see, we marked the spot on the phone where the sensor was, and the magnet was aligned with the east-west axis, and then we just measured the distance between the magnet and the sensor for different target BX values. So our observations were that far away from the magnet, the magnetometer on the iPhone measured an X value closer to 0, whereas when the magnetometer was placed closer to the magnet, the X component increased. So here are the calculations for the magnetic dipole moment. As I was saying before, we used the line from the line formula from our data collection to plug into the distance dependence formula and solve for the magnetic dipole moment. So here is the code for the computational model. As you can see on the left on line 23, I plugged in the dipole moment that we calculated in the previous slide. And then the rest of the code, you can see we wrote the B field formula, and then on the right side was code to create the arrows. And then here's more code for creating the arrows to visualize the field. And then also on the right, you can see the computational model results, and then at the bottom, the theoretical results for the B field. So as mentioned in the beginning, the experimental B net was larger than the theoretical. This could be due to external electric fields or experimental error. So for the what if you hadn't oriented your experiment to compensate for magnetic north and instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field, this would change the result for both the measured x and y components, and it would contribute to both components depending on the angle deviation from true north. And then what if you were to stick two magnets together end to end? Well, this would increase the magnitude of the magnetic field because of superposition, and the new magnetic field would be close to doubled. Potential sources of error were, like I said before, external sources of electric field, and then using the iPhone and human error and like software differences. That's all. Thank you.